everyone. In this lesson, we're going to be looking at polygons and their angles. Again, our essential question, how can algebraic concepts be applied in geometry? Let's first talk about polygons and what they are. It's a simple closed figure formed by three or more line segments. So some examples that I have here, we all know that's a triangle. 3 sides make a triangle, 4 sides make quadrilaterals, and so on. 5 sides is a pentagon, and we're going to be looking at several examples there. Interior angle sum of a polygon. The sum of the measures of the interior angles of a polygon is represented by this algebraic expression. N minus 2 multiplied by 180, where n is going to represent the number of sides in that figure. For instance, if we had a quadrilateral, we would know that that's 4 sides. So to find the sum of the interior angles in this 4-sided quadrilateral, we're going to substitute 4 in for n because it has 4 sides. So when we do that, instead of n minus 2, we're now going to have 4 minus 2. Remember, order of operations, we're going to take care of our parentheses first. So 4 minus 2 gives us 2. So we're going to be multiplying 2 times 180. 2 times 180 is 360. So that means inside a quadrilateral or a 4-sided figure, there is a total of 360 degrees. A special polygon is called a regular polygon. A regular polygon is a polygon that has equilateral, is equilateral, which means all of its sides are the same measurement, all the sides are congruent, and it's also equiangular, which means that all of those interior angles are the same measurement as well. So a regular polygon means that all of the sides are the same length, equilateral, and all the measurements of the angles are congruent, which makes it equiangular. A common example of a regular polygon is a square. A square, we know all 4 sides are going to be the same measurement, and we already know that all 4 angles are going to be the same measurement as well. So since you know that a regular polygon is equiangular, we can find the measurement of each angle by finding the total degrees in that figure, which we just did in the previous example, 4-sided. We're going to put 4 in for the number of sides. So there's a total of 360 degrees inside this square. But now to find the measurement of each individual angle, we'll just divide that by 4 since there's 4 angles, and we find out that each of those angles inside are 90 degrees. All right, we're going to look at 2 examples. The first one, we want to find the sum of the measures of the interior angles of a decagon, okay? So what we want to know is how many total degrees are inside a decagon. Now, I'm not going to draw this decagon because it is going to look very messy. However, we do need to know how many sides that a decagon has. A decagon is 10 sides. So remember, our expression that we want to use is the number of sides minus 2 times 180. So we know the number of sides is going to be 10. So we're going to substitute 10 in place of n. So now we're going to make sure we take care of our parentheses first. So that's going to be 8 times 180. When you multiply those together, you should get 1,440 degrees. So there is a total of 1,440 degrees inside a decagon. In this last example, we're going to do a little more practice with a regular figure. Each chamber of a bee honeycomb is a regular hexagon. Find the measure of an interior angle of a regular hexagon. So this one's a little different. They don't want the total degrees inside. They want to know what one of those angles will measure. And since we were told that it's regular, we know this hexagon is going to be equilateral, all the sides will be the same measure, and it's also going to be equiangular, which means all 5 angles inside that hexagon are going to be the same measurement as well. Now, my picture does not suggest that because I'm not very good at drawing these. However, the first thing we need to know is that a hexagon erase that figure altogether. A hexagon has 6 sides. Okay? So we're again going to use this expression n minus 2 times 180. So we're going to put 6 in place of n for the number of sides. Okay? Then we're going to do our subtraction. So that's going to be 4 times 180. 4 times 180 gives us 720 degrees. Now that's the total degrees inside that hexagon. They want to know what is going to be the measurement of one of the angles. Now since we know they're all the same measurement, all we need to do is take that 720 and divide it by 6. 720 divided by 6, and I'll just check my math here, is 120 degrees, and I hope that you can see this in the video, I'm so sorry. Each of the angles in that regular hexagon will be 120 degrees because they are all the same measurement and they'll total up to 720. So we'll do more examples of this in class.